Hey there, CJ Math students, and welcome to Notes 2.12. So basically what we're trying to do today is take our integer rules. Remember, they are SSAK, same signs, add, keep the sign, and DSSM, different signs, subtract, more, keep the sign that we have more of, and apply those to other rational numbers. So apply them to fractions, apply them to decimals. So to see if we can kind of extend this learning and these rules that we have to kind of more complicated numbers. So suppose the 7th grader's birthday is today. He is 12 years old. How old was he 3.5 years ago, right? 3.5 years ago. Think about what that means. Is that in the future? Is that now? Is that in the past? Write an equation and use a number line to model your answer. So basically what we're really wanting to do right here is 12 minus 3.5, because that's 12 years ago. Now there's a whole bunch of different ways we could do this, right? We could say, oh, 3.5, that's really 3.5, and we could do 12 minus 3.5. We could keep this as fractions, and we could do it that way. But I really want us to practice splitting a mixed number, and this is what I mean. So first of all, we have this 12 minus 3.5. I want to take the whole numbers and say I want to do 12 minus 3. And then I want to take the fraction of this mixed number and say, all right, that's now becoming plus -1/2. Why is it -1/2? Because I have a minus 3.5. So it's not just taking 3 wholes away, it's taking 3.5 wholes away. So I want to make sure both the whole and the fraction are subtracted, or in this case, the fraction is negative. So when we do this, 12 minus 3 is 9. And then I have 9 plus -1/2. Right? So I'm going to have to borrow from my 9 in order to even do this, right? So when I borrow from my 9, I get 8, and then the fraction I'm borrowing 1 whole, right? I just look here, it's 2/2 plus -1/2. And now, look, I can do this, right? My whole number stays the same, it's 8, and then 2 plus -1, that's a different signs subtract more. So 2 minus 1 is 1, it's positive 1, because I have more positives than I do. So 8.5. Now that's a super difficult way to just do probably what some of you were like, wait, I know this says 12 minus 3.5, and 12 minus 3, that's 9, take away another 0.5, that's 8.5, 8.5, right? But I want you to be able to start to see this idea of splitting mixed numbers and making sure that you understand that, hey, if the whole number is negative, the fraction is also negative, because it's going to help you out when we start to work with complex rational numbers like mixed numbers that are both positive and negative. So to graph this on the number line, the first thing you want to do is actually make 0. So 1, 2, 3, 4, 5, 6, 7, 8. We'll say 0 is like right here, right? So moving 12 spaces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, say 12 spaces where he started, and then he moved back 3.5 spaces, so 3.5 years ago. So there's 1 year, there's 2 years, there's 3 years, and then 3.5 would be right in here. So there's the 8.5 that we're talking about. So 3.5 years ago, this student was 8.5 years old, right? So let's go ahead and do some practice with these splitting mixed numbers. Right, so -2.5 plus 6.5. The good news, hey, we got common denominators, so we're good to go. But splitting these mixed numbers, this number becomes -2 plus -1/2. Right, the fraction part of a -2.5 is also negative, and then this number becomes plus 6 plus 1/2. Right, if the whole number is positive, then the fraction is also positive. So let's use commutative property of addition, right, where we can reorder stuff and put the whole numbers by each other and the fractions by each other. So we'll say this is now -2 plus 6 plus -1/2 plus 1/2. And the beautiful thing is here we have a DSSM, right? Different signs subtract, keep the sign we have more of. 6 minus 2 is 4. There's more positives, so 4. And here we have the additive inverse, right? We have a -1/2 and its opposite, 1/2. And we know that the additive inverse will always equal 0, right? So it's 4 plus 0. So our answer is just 4. Or you could literally just say 4, just cross that off, right? So using the number line, you would say, all right, at -2.5, so here's -2. -2.5 is actually going to be between -2 and 3. And then we're going to move 6 spaces to the right, 6.5 spaces to the right. So moving one space is actually going to look like this. You're going to end up in the half. So that's 1, 2, 3, 4. See, I'm jumping halfway in between every single time. 5, 6, and then a half is that extra little space. Boom. All right, so you started here, and you ended at 4. Right? Let's try the next one. 1 1/2 is really 1 plus 1/2, and then this is really plus -2 plus, what's the fraction? -1/4. So now if I use commutative property, this is really 1 plus -2 plus 1/2 plus -1/4. And so now, unfortunately, yeah, we got to do common denominator. So times 2, right? And we get 1 plus -2 plus 2/4 minus, plus -1/4, right? Forgot to say plus there. So now let's do this addition, right? So 1 plus -2, DSSM, different sign subtract. 2 minus 1 is 1. But remember, I got more negatives. So that's -1. So this equals -1. And then 2 plus -1 is, again, a DSSM. But that's 2 plus a -1. So 2 minus 1 is 1, but that's positive. So plus 1/4. So we're not done, right? Because I have a negative and a 1/4. I cannot just smush these together because one's negative and one's positive. So what do? I'm going to change this negative number into a fraction. 1 whole. -4/4 plus 1/4. That's kind of like borrowing, right? And when I do that, I can see, okay, now I can solve this. -4 plus 1 is -3/4. This is super complicated, I know, and it's going to take us a little while to get us. But -3/4 would be about, right, -1/4, -2/4, -3/4, right there, -3/4. And if you think about it, this is really 1.5 plus -2.25. So it's like if you had $1.50 in your pocket, but you owed somebody $2.25. You could give that $1.50 back, but how much more money would you owe them? You would still owe them 75 cents, right? And that's where that -3/4 comes in as our answer. Tricky stuff, I know. This is the end of part 1.